So, have you ever wondered how these massive applications, like Netflix or Google, manage to run so smoothly for millions of people all at once? It's definitely not magic. It's actually the result of this really fascinating evolution in how we run software. So today, we're going to trace that journey, starting with clunky old physical servers and ending up in this super efficient world of containers that powers pretty much everything now.
All right, to really get where we are now, we have to rewind and look at the problem that started this whole thing. See, in the early days of the internet, things were just incredibly inefficient. The basic rule was simple and, honestly, unbelievably wasteful. One server got one single application. That's it.
And this slide just lays out the problem perfectly. You look over there on the left at the traditional model, you've got a whole powerful server just for email, and it's barely breaking a sweat, running at only 30%. Then you have another one for a simple firewall using a tiny 6% of what it can do. And this wasn't some rare thing, this was just how it was done.
And here's the bottom line. Companies were spending a ton of money on these expensive, power-hungry machines only to let most of that power just sit there, completely idle. Think about it. It was a huge drain on everything. Electricity, cooling, physical space in the data center. Something had to give. A revolution was overdue.
And that revolution? It came in the form of virtualization. This was the first huge leap forward. This brilliant idea that let us run a bunch of virtual computers all on one single physical machine.
And this slide just perfectly illustrates the solution. Now look at the right side. Instead of 3 separate, lazy servers, we've got one physical machine running all 3 of those apps: email, firewall, and phone services. And each one is in its own isolated virtual world. And just like that, server utilization skyrockets from under 30% to 60%, maybe even more. We're finally using the horsepower we paid for.
So how does this magic trick actually work? Well, the secret sauce is a piece of software called a hypervisor. Think of it as a super smart traffic cop that sits right on top of the physical hardware. Its job is to carve up that hardware into multiple completely independent virtual machines, or VMs. And the really cool part is, each VM has no idea it's sharing. It thinks it has its very own processor, its own memory, and its own storage, even though they're all just slices of the same pie.
Now, this tech comes in 2 main flavors. Over on the left, you've got your Type 1, what they call bare metal. This thing runs directly on the hardware itself, so you get maximum performance. This is the heavy hitter you'll find in big data centers. On the right is the Type 2, or hosted hypervisor. This one's a bit different. It runs on top of an operating system you already have, like Windows or Mac OS. It's perfect for a developer who needs to, say, run Linux on their laptop for a project.
And this idea of virtualization was so game-changing that it didn't just stop with servers. No way. It spread to basically everything. We started virtualizing storage to lump all our disk drives together. We virtualized networks to build these complex, walled-off systems and software. We even started virtualizing entire desktops, which let people access their work computer from literally anywhere. This one idea really built the foundation for the entire modern cloud.
But, as great as virtualization was, it wasn't perfect. It had a bit of a problem. Every single virtual machine was still its own full-blown computer, which meant it had to carry around its own entire operating system. So VMs worked, but man, they were heavy and they were slow to get going. The evolution wasn't done yet. A newer, leaner, meaner solution was just around the corner.
Here's a good way to think about it. A virtual machine is like building a whole separate house for every single one of your applications. Each house needs its own concrete foundation, its own plumbing, its own electrical wiring. That's the entire operating system. It works, for sure, but it's a ton of overhead if all your app really needs is a single room.
And that brings us to containers. A container is a much smarter way to package things. It bundles up an application with all the files and libraries it needs, but, and this is the absolute breakthrough, it shares the operating system of the host machine. So instead of building a whole new house, it's more like renting an apartment. All the apartments in the building share that one big foundation and all the main plumbing, which makes them incredibly lightweight and super fast.
Okay, so let's put these 2 technologies right up against each other. This is the real showdown that pretty much defines all of modern software development. This image just nails the difference. Look on the left, with the virtual machines. See how each one has its very own guest OS? That's the heavy, slow part we've been talking about. Now, look to the right, at the containers. They're all sharing a single operating system. That entire bulky layer is just gone. So the key takeaway is this. VMs pretend to be hardware, while containers just pretend to be an operating system. And the impact of that difference in the real world is just staggering. I mean, just look at this table. Startup time for a VM, we're talking minutes. For a container, seconds. Seconds. And the size? A VM is measured in gigabytes. A container is in megabytes. This is not a small improvement, folks. This is a fundamental, game-changing leap in speed and efficiency.
So this new world of lightweight, disposable containers was amazing, right? But it created a brand new challenge. How on earth do you manage thousands or even millions of these things all at once? Well, you need a whole new set of tools. So let's welcome in the modern era, powered by two superstars, Docker and Kubernetes.
So first we got Docker. Docker was the tool that made containers easy for everybody. It totally simplified how you package up an application into one of these neat portable units. Then came Kubernetes, which you can think of as the conductor of a massive container orchestra. It's the brain that automates deploying, scaling, and managing all of those containers for you.
This diagram really shows you how they fit together. See, Docker is the one actually building and running the individual containers on a machine. Kubernetes is the management layer that sits on top of all that, acting as the brain, orchestrating all those Docker containers across a whole fleet of servers. They're not competitors at all, they're partners, and this partnership is what's running most of the modern internet today. So we've seen this incredible journey, right? This constant push for more and more efficiency by just adding new layers of abstraction. We went from physical servers to virtual machines that abstract the hardware to containers that abstract the operating system, and it just leaves us with this one really fascinating question. What's next? What's going to be the next layer of abstraction that makes all of this even simpler, even faster, and even more powerful?